Hi guys, my name is IBM and today I want to solve Physics 9702 paper 1. These are multiple choice questions and basically I'm solving October-November 2022. This is going to be component paper 1-3. So without wasting time, I would like to take you to the question paper. So here we are on the question paper. The paper is supposed to be 1 hour and 15 minutes. I'll try my level best to keep time. So I will not read through the instructions. I will not go through the data, the formula. You can go through this. I'll just take you straight to the question paper, to the questions. Question number 1. A train of mass 600,000 kilograms moves with a speed of 100 kilometers per hour. What is the order of magnitude of the kinetic energy of the train? So I think this is direct because they have given us the mass and the speed. All we need is to change the speed to meters per second. So this one is going to be the same as 100 times 1000 to change distance to kilometers. And per hour, 1 hour is 3600 to change this to seconds. So that is going to be the speed. So from my calculator, I'll check 100 times 1000 divided by 3600. So I'll just write this as a fraction. So this is, okay, let me just write 27.8 meters per second. So the kinetic energy is supposed to be a half mv squared. So this will be a half times the mass, which is 600,000, times the v, which is 28.8 squared. So I'll first square the answer here, then times 600,000. Times 600,000, then divide by 2. So this is 2 times 2.3 times 10 to the power of, so that is 3678. So this is to the power of 8, which makes our answer to be B. What are the SI base units of EMF? Remember, EMF is defined as work done per unit charge or energy transferred from chemical energy to electrical per unit charge. And remember, work done can also be force times distance, then divided by charge, which charge can also be I times T. So the units for force is newtons, or it is kilogram meters per second squared because it is MA, then times distance, which is in meters. The current is amperes, then times T, which is in seconds. So when I simplify this, I have kilogram. The meters should be squared. So I cancel out D. Then S should be power minus 3 because the S in the denominator goes up, so it's power minus 3. Then, so it means S should be power minus 3, so I cancel out C and A. Of course, it leaves the answer to be B, so it is S power minus 3 times S power minus 1. A digital meter is used to measure the current in the circuit. The reading on the meter fluctuates. That means it keeps varying between 3.0 to 3.08. The reading on the meter have an accuracy of plus or minus 1%. That means the accuracy is 1 over 100. What is the true value of the current with its uncertainty? So first of all, let's find the mean average. So we need to find the mean value. The mean value is going to be, of course, 3.04 plus 3.08 divided by 2. So for a value which fluctuates, we take the average. I think this is going to be 3.06 amperes. And notice that all answers have 3.06 amperes. Then we have to check the uncertainty. To find the uncertainty here, we need to find the highest value, the most likely possible value, the highest possible value, and the lowest possible value. Then we subtract and divide by, we get half of the range. So the minimum value The minimum value, we shall look at the lowest, then we subtract the most possible uncertainty in the minimum value. So the lowest is 3.04 minus the most possible uncertainty in the lowest, which is, remember, it is plus or minus 1%. So it is 1 over 100 times the least possible, the value which is obtained there, which is 3.04. This is the least possible value for that fluctuation. So this is going to be 3.04 divided by 100. Then I subtract this from 3.04. So this gives me to three significant figures. This is going to be 3.01 amperes. That is the minimum value. Then I can find the maximum value, the maximum possible value, with that uncertainty of 1 plus or minus 1%. So this maximum is going to be 3.08 minus, this, because it's maximum, it is going to be plus. So this is going to be plus 1 over 100 times 3.08, which is going to be 3.08 plus, that is 3.08 divided by 100. So to three significant figures, this is going to be 3.11 amperes. So the uncertainty in this current is going to be half of the range. So it is half of 3.11 minus 3.01. So 3.11 minus 3.01 divided by 2. So this is giving me 0.05. So it means the answer is going to be automatically C. Which quantity is a vector quantity? Of course, a vector quantity has both magnitude and direction, and for this we know it is going to be the weight, because the weight of a body acts vertically downwards. So the weight has magnitude and direction, which is always vertically downwards. So the answer here is automatically D. A stone is projected horizontal at time t equals to 0 and falls. Air resistance is negligible. The stone has a horizontal component, VH. So VH is horizontal. Remember, air resistance is negligible, which means acceleration in the vertical is a constant, which is G. And of course, acceleration in the horizontal is going to be 0, because there's no resultant force in the horizontal. So acceleration in the X is going to be 0. A vertical component of velocity is VV. Which graph shows how VH and VV vary with time? Because there is no acceleration in the horizontal, the acceleration in the horizontal is 0, which means velocity in the horizontal remains constant. So VH must be constant. So velocity in the horizontal must be a horizontal line. So this means this is wrong. Velocity in the horizontal must be a horizontal line. So we have to choose between A, C, and D, because A, C, and D are showing horizontal lines for VH. Then how about velocity in the vertical? Since the acceleration in the vertical is a constant, which is G, so it means the gradient should be a constant. The gradient of velocity against time should be a constant. So gradient of V against t should be equal to a constant and not 0. So it means the line cannot be horizontal for V in the vertical, because if it is horizontal, it means the gradient is 0, which means the acceleration is 0. So it should not be horizontal. And it is a constant. The gradient should be a constant. That means if it is not a straight line, then it is wrong. So C is wrong, because C is showing, this one shows acceleration is increasing, because the gradient of this curve is increasing. This one also shows that the acceleration is increasing, but it's negative. Here, acceleration is also increasing, but it is negative. This was increasing but positive because the gradient is increasing but positive. Here the gradient is increasing but negative. So in both cases, the acceleration here is not constant. So it means our answer is going to be A, where a straight line means a constant gradient for velocity time graph, which means a constant acceleration. On Earth, an object takes time t subscript e to fall from rest through a vertical distance h. On the Moon, the same object takes time tm to fall from rest through the same vertical distance h. So they're going to fall through the same vertical distance. The acceleration of the ratio acceleration of free fall on the Earth over acceleration of free fall on the Moon is equal to 6. Air resistance is negligible for the object on the Earth and on the Moon. What is the ratio TE over TM? Okay, so if air resistance is negligible, the accelerations are going to be constant, so the equations of motion can apply. So I can use S equals to UT plus a half AT squared. S is going to be H equals to, I'm now considering the Earth, so this is going to be a half times, of course, initial velocity is 0. For free fall, initial velocity is 0. So I'm taking a half times G on Earth times T on Earth. This is going to be squared. Then on the Moon, remember they fall through the same distance. So again, using the same equation, H is going to be a half times G on the Moon times T on the Moon, and this is squared. So I have to combine these two equations. I will just equate them. So it means a half G on the Earth, T on the Earth squared should be equal to a half G on the Moon, T on the Moon, and this is squared. So half has cancelled. I want the ratio G on Earth divided by G on the Moon. So the other side I will remain with the T on the Moon squared divided by T on the Earth squared. But they said acceleration of free fall on the Earth over acceleration of free fall on the Moon is 6. So on the left hand side, I'll put there a 6. So it means T on the Moon over T on the Earth, but this is squared, is going to be equal to 6. But then in the question, I want the reciprocal, so I'll get the reciprocal both sides. So T on Earth over T on the Moon is going to be equal to, of course, this is squared, is going to be 1 over 6. And when I find the square root of both sides, it means T on the Earth over T on the Moon is going to be 1 over the root of 6. So this means my answer is going to be B, 1 over the root of 6. A cyclist in still air pedals as hard as she can. She reaches maximum speed. However, after a certain time, her maximum speed again increases. Okay, so she pedals as hard as she can and reaches maximum speed. And after a certain time, again, her maximum speed increases. So it increases beyond what she has reached. What could be a possible cause of this? She cycles into wind. Of course, wind would reduce the maximum speed. She cycles over rough ground. Friction would reduce the maximum speed. She sits more upright on the bike. Of course, sitting more upright would increase air resistance, which would reduce the maximum speed. Perhaps she starts to travel down the hill. Of course, if she's descending down the hill, the maximum speed should therefore increase. So the answer is going to be D. A ball of mass 0.5 kilograms hits a vertical wall at a speed of 12 meters per second and bounces. That means if this is positive velocity, the other one is negative velocity, because it is in the opposite direction. What is the average force on the ball due to the collision? So, of course, the average force is going to be equal to the rate of change of momentum. So this is going to be the change in momentum. Remember, this is m times change in velocity divided by change or the time. So this is going to be the mass 0.5. The velocity changes from 12 to -8. So I subtract -8 divided by the time, which is 0.1. So this gives us, I'll just press my calculator, 0.5 times 20 divided by 0.1, which gives you 100. So the answer is D. An air bubble in a tank of water is rising with the terminal velocity, that is constant velocity. So if it is moving with the terminal velocity, constant velocity, it means the resultant force F, which is mass times acceleration, is equal to 0. So the resultant force is 0, the acceleration is 0. The forces acting on the bubble are X, Y, and Z, as shown. So that means, first of all, X, which is acting upwards, should be equal to Y plus Z, because the resultant force should be 0. Okay? So it means X should be equal to Y plus Z. That means I have to ignore B without even checking, because they are saying X is greater than Y plus Z. I have to ignore D because it's also saying X is greater than Y plus Z. So I have to choose between A and C. So A is saying Z is the viscous force. Remember, this was an air bubble, which means its weight is extremely small. For an air bubble, its weight is extremely small. And if the weight is extremely small, it means the upthrust and the viscous drag are bigger. So it means if X is automatically the upthrust, then downwards, Z must be the viscous drag, and Y must be the weight. Because for an air bubble, we expect the weight to be extremely small. And if the weight is extremely small, then it means the upthrust is bigger. And if the upthrust is bigger, it also means the drag is also going to be increasing. The drag increases to tend, because the weight does not change. And for equilibrium, the drag should increase so that it adds to the weight to give us a bigger upthrust, to balance the bigger upthrust upwards. So it means Z is the drag, which is the only force which can increase. So the answer is most likely going to be A, where Z is the viscous force, Y is the weight of the bubble, and X is equal to Y plus Z. So the answer is automatically A. I'm saying Z cannot be the weight of the bubble, and weight cannot be the viscous drag, because if Z is the weight of the bubble, then it means as it falls, Y is most likely Y is the one which would be increasing, which is possibly not going to be possible. Z is the one which has increased because it has added to the weight to balance with X. Two blocks are at rest on a frictionless horizontal surface. One block is made of wood and the other block is made of steel. A steel ball is fired horizontally with a speed v at the wooden block. The ball embeds itself in the block, and the ball and block move together after impact. So they move together as a single ball after impact. A second identical steel ball is fired horizontally with speed v at the steel block. The steel block then rebounds along its original path with a speed v over 2. The wooden block and the steel block have equal mass. Okay, they have the same mass. So I will say the mass, they say the wooden block and the steel block have the same mass. Okay. Which statement about the blocks immediately after the collision is correct? Which statement about the blocks immediately after the collision is correct? So starting from the first part, the mass here, the momentum here before impact is going to be m times v. Then the momentum here after impact, let capital M be the mass of the wooden block. So here after impact, I'm going to use a small m for the mass of the ball. So after impact, we have the mass of the ball plus the mass of the wooden block. And I'm going to call this speed here U1 because V has already been taken. So by conservation of momentum, I will have that M times V is the same as M, so this is capital M, is the same as M plus capital M times U1, which means U1 is going to be equal to capital M over M plus capital M, then times V. So remember, M is the mass of the steel ball. M is the mass of the steel ball. So this value here, the denominator is bigger than the numerator, so it means U1 is automatically less than V. U1 is less than V. That's number one. Number two, let me consider the steel ball. The steel block. So here we have, remember they had the same mass. So here it is M times V, initial momentum. No, the blocks were at rest. So this is small m, not capital M. So small m plus capital M, this is small m. It is the ball which was moving, so this is small m. Yeah, but it doesn't change the meaning. It still means the denominator is bigger than the numerator, so U1 is less than V. So here again, small m times V, because steel was at rest after collision. After collision, this one moves to the left-hand side, so its momentum is going to be negative m times V over 2. And let's say this one continues to this direction, and its momentum is going to be capital M. Let its speed be U2 in that direction. So by conservation of momentum again, I will simply say m times V is again going to be equal to negative mv over 2 plus capital M U2. So if I simplify this further, I'm going to collect like terms. So I have m into v plus v over 2 is equal to capital M times U2. So I think this is v plus v over 2. I think that is 3v over 2. So I have that m times 3v over 2 is equal to m times, this is capital M times U2. So making U2 the subject means U2 is going to be equal to small m over capital M, then times 3 over 2 times V. And when you look at this expression here, it is 3 over 2. It is 3 over 2 times m over m. So when you look at this expression here, you notice that U2 is most likely going to be greater than V, because when you compare this fraction here, 3 over 2 times m over m times V, it is most likely going to be that U2 is greater than V. Or alternatively, we can compare, because the question is, which statement about the blocks immediately after the collision is correct? The first one is saying the blocks must travel with the same speed. First of all, that is wrong because the two expressions are not the same. So that one is wrong. The steel block must travel faster than the wooden block. The wooden block must travel faster than the steel block. The masses of the blocks and the steel ball are needed to determine which block travels faster. The masses of the blocks and the steel ball are needed to determine which block travels faster. I'm very certain that if I substitute if I combine these two equations here, most likely m is cancelling out. If you do mathematics, let me try to show you that the m cancels out. From the first expression, we have that u1 is equal to m over m plus capital M, so it will be 1 in the denominator over 1. I'm dividing everything by small m, though, so it will be 1 plus capital M over small m, then times V. So I can substitute, I can remove capital M over small m by using this expression here. So capital M over small m from this expression here, I'm just trying to show you the algebra so that I arrive at a simpler discussion. So capital M over small m, if I make capital M over small m the subject, it means I will have 3 over 2 V over U2. So I can substitute here for capital M over small m, so I'll have this as 1 divided by 1 plus 3V over 2U2. Then I multiply this by V. So you notice that M is not needed, so the mass disappears. But if you want to tell which one is greater, you can still simplify this further. If I try to simplify this further, I want to see which one is greater then. So I have U1 equals to LCM, the 2U2 goes up, divide by, so here I have 2U2 plus 3V, then times V. If you try to cross multiply and simplify this, I'm trying to see if I can make U2 the subject or U1 is the subject, but you notice that U1 is twice U2 times V over 2U2 plus 3V. Okay, so it means U1 into 2U2 plus 3V is equal to 2U2 times V. So when I collect like terms here, I'm trying to collect like terms, but if you're a mathematician, you notice that when you look at these two expressions, you notice that U2 is actually greater than U1. By just looking at these two this expression here, U1 into twice U2 plus 3V is equal to twice U2 times V. So you can notice that actually U2 is actually greater than, it's going to be greater than U1 because you'll divide by several fractions. You'll divide U1, you'll divide U2. To find U2, you'll divide, or to find U1, you'll actually have to divide U2. So that means U2 is most likely going to be greater than U1. So the question is, which statement about the blocks immediately after the collision is correct? So the steel block must travel faster than the wooden block. Of course, this is going to be the most appropriate argument. The steel block must travel faster than the wooden block. So which diagram shows a couple? Remember, we have two equal but opposite forces. This is not a couple because all forces act in the same direction. This is not a couple because they are not equal but they are not opposite forces. Then here, the line of action of this force, when I prolong it further, it will meet with the other force. Their lines of action never meet, so this is not a couple. So the answer is going to be D. The lines of action of these forces never meet. They're equal and opposite. The student states that if an object is in equilibrium, the sum of clockwise moments about a point X is equal to the sum of anticlockwise moments about point Y. This is true if point X and point Y are the same point. Which condition would make the student's statement correct? Either X or Y is the center of gravity of the object. That is not true. We are taking moments at X and taking moments at Y. If the principle is to be if the principle of moment is to be valid, X and Y should be the same point. So the answer is automatically going to be D. X and Y are the same point on the object because we can't take moments at two different points and then we equate them. So 13, a uniform rod of length 30 centimeters and weight 5.2 newtons is attached to a wall by a hinge at one end. The other end of the rod is supported by a wire so that the rod is horizontal and in equilibrium. The wire is at an angle 40 degrees to the horizontal. So it means there is tension in the wire here. We call the tension T. But since we don't know the perpendicular distance, I'll resolve T vertically. Resolving T vertically gives me T sine of 40 in the vertical. So what is the tension in the wire? So I am going to take moments about the hinge. Taking moments about the hinge. Is it a uniform? It is a uniform rod, so its weight of 5, because it is uniform, its weight of 5.2 newtons acts at the midpoint. So this is going to be 15 centimeters. So I will say the tension T sine of 40, that is the force, times the perpendicular distance from the point where I'm taking moments, which is 30 centimeters, should be equal to 5.2 newtons times the perpendicular distance, which is 15 centimeters. So I just press my calculator to find T. On the left hand side, I have 5.2 times 15 divided by 30 divided by sine of 40. So this is 4.0. So the answer is going to be B. Water is pumped through a nozzle at the end of a hose. The nozzle has a circular cross-section of diameter 50 millimeters. As a mass of 100 kilograms of water takes a time of 2 seconds to move through the nozzle. The density of water is 1000 kilograms per meters cubed. What is the speed of the water in a nozzle? Okay, I think this is very easy. First of all, we know that density is equal to mass divided by volume. This is mass. Volume is cross-sectional area times another length. That is volume. And remember, area is pi d squared over. Area is pi d squared over 4. And since we have the diameter, so I have to introduce area here. So I mean pi d squared over 4 here. So the 4 goes up, it becomes 4m. Where there is area, remember I've put pi d squared over 4. So it is pi d squared then times another length L. Okay, so I want to find the speed. So precisely I am saying the density, rho, is 4m over pi d squared times L. So if I make L the subject, that is the length or the distance which the water moves, L is going to be 4m divided by pi d squared times rho, that is the distance. So speed is going to be the distance L divided by the time. The time is 2 seconds. So this is going to be 4 times the mass, which is 100, divided by pi times the diameter, which is 5 times, so it is 50 times 10 to the power of minus 3, but this is squared, times the density, which is 1000. Then in the denominator I have, because I'm dividing by t, so I'll say times 2.0. So I will have, starting with the denominator, I have 2 times 1000 times pi, then times 50 exponent minus 3. This is squared. So I have 4 times 100, which is 400, divided by the answer. So this is 25.46. So this is 25.46, or approximately 25. So the answer is going to be C. A solid wooden cube rests on a horizontal surface. What gives the pressure exerted by the weight of the cube on the horizontal surface? Pressure. Of course, we know pressure is equal to force over area, and the force is going to be the weight over the area. The weight is normally given by m times g, then we divide this by the area. Then, of course, if we don't have the mass, then we know that mass is density times volume, then times g divided by the area. And if we don't have the volume, we have density, volume is cross-section area times another length, then times g divided by the area, where here the area cancels. So let's see what is given here. The product of the acceleration of free fall, which is g, and the density, which is rho. So g and rho do not give pressure. The product of the acceleration of free fall, which is g, the density, which is rho, and the side length L of the cube. So that is rho Lg. Rho Lg. So the answer is going to be B. Which expression could be used to calculate power? Remember, we know that power is equal to the work done over time taken. And work done also is force times the displacement divided by time, which would be force times velocity. So we have to check current squared over resistance. If it is electrical power, power will be I squared R, which could be V squared over R, which could be I times V. That is for electric power. So it means A is wrong. The answer is going to be B. Current times resistance squared, this is wrong because it's I squared times R. Weight over time, it is work done. Work done over time, so this is wrong. A bungee jumper jumps from a platform and is decelerated by an elastic band cord as shown. That means the speed decreases, decelerated. So the speed decreases when when the cord starts stretching. So when the jumper makes the jump, his initial gravitational potential energy is converted into kinetic energy and into elastic potential energy. At which part of the jump are all the three types of energy non-zero, not zero? So when he's at the top here, before he starts jumping, we have potential energy is mgh. It is not equal to 0, but he has not started moving, so kinetic energy is equal to 0. Elastic potential energy is also equal to 0 because the cord is not stretching. So at the top, if there is anything to do with the top, that is wrong. On the platform before the jump, so that is out. So when is let's consider when he has reached at the bottom of the ground. So here elastic potential energy goes to 0 when it reaches here. Kinetic energy becomes maximum because it hits, the kinetic energy decreases when when the elastic potential energy starts increasing. So elastic potential energy is maximum when it reaches the ground. But kinetic energy is somewhere in between there. Or kinetic energy decreases, I would say decreases, it goes to 0 anyway. Because when it reaches the ground, as he loses elastic gravitational potential energy, he will first get kinetic energy, but the kinetic energy goes on reducing because the kinetic energy is becoming elastic potential energy. So at the bottom, not all of them are going to be 0. So let's look for the bottom. At the bottom of the jump when he is stationary. So here elastic potential energy is maximum, so it's not 0. So we have eliminated those two. Elastic potential energy is maximum, but potential energy here is 0. Here we said both kinetic and elastic potential energy were 0. So we have to choose between B and C. And B says, on the way down, before the cord has started to extend, if the cord has not started to extend, this still means elastic potential energy is 0. Because elastic potential energy stops being 0 when the cord starts stretching, since elastic potential energy is equal to a half kx squared, where x is the extension of the cord. So if it has not started extending, then elastic potential energy is going to be 0. So the answer is going to be C. on the way down as he decelerates. Of course, elastic potential energy starts increasing when it's decelerating. Kinetic energy starts decreasing when it's decelerating because the chord is stretching, elastic potential energy is increasing, but the speed is decreasing, kinetic energy is decreasing, so it's not zero still. And the height is decreasing, so it means elastic potential energy, gravitational potential energy is decreasing, but it's not zero, so the answer is going to be C. An object is displaced horizontal to the right in a uniform vertical gravitational field. Which statement describes the change in the gravitational potential energy of the object? Okay, so we know that gravitational potential energy is equal to mgh. It is displaced horizontally, which means h is remaining constant. Because h is remaining constant, because moving in the horizontal, the vertical distance from the ground is remaining constant, so it means the gravitational potential energy is not changing. So the answer is it does not change with the displacement. It is displaced horizontally, but the vertical distance is remaining the same. So it does not change with the displacement since the vertical distance is remaining the same. A copper wire of length 3.6 meters and diameter 1.22 millimeters is stretched by a force of 37 newtons. The wire obeys Hooke's law, and the Young modulus of copper is 1.17 times 10 to the power of 11 pascals. Which extension is caused by the force? Extension caused by the force. Okay. So first of all, we know that Young modulus is stress divided by strain. Remember, stress is force over area, and strain is extension of original length. So when I divide, I get the reciprocal. So it becomes original length divided by extension. And also recall that area is going to be pi d squared over 4. So which means the Young modulus is going to be 4f L naught over pi d squared times E. Okay, so let me come to this side. So I'm going to make E the subject. Extension is going to be equal to 4f L naught divided by pi d squared times Young modulus when I make E the subject. So we make substitution. So it will be 4 times f, which is 37, times original length, which is 3.6, divided by pi, and the diameter is 1.22 times 10 to the power of minus 3, and this is squared. Then times the Young modulus, which is 1.17 times 10 to the power of 11. So I'll just press my calculator. 4 times 37 times 3.6 divide by, let me first divide by pi times 1.17 exponent 11. I'm still dividing by 1.22 exponent minus 3, but this is squared. So this is giving me 9.7 times 10 to the power of minus 4. 9.7 times 10 to the power of minus 4 meters. Okay, so the answers given here are in millimeters, so I have to multiply this by 1000. So times, because 1 meter is 1000 millimeters, so this is the same as 0.97 millimeters. So the answer is going to be C. A spring has spring constant K. The spring obeys Hooke's law and experiences extension X when a force F is applied to it. So when it is one spring, I'm just considering one spring. If it is one spring, the extension is X, and the spring constant K is K. So the diagram shows two of the springs. Now there are two. So when there are two, something must change. So when there are two springs, total extension changes. If there are two, total extension is half of the spring of just one, so this is going to be a half of x. I can even predict what the total constant would be, of course, by looking at the reciprocal of the coefficient. So total constant will be twice of k. Let's see what the question wants. What is the extension and total elastic potential energy of this arrangement when the same force F is applied? Okay, for the first one, the elastic potential energy is going to be equal to a half times, let's say F times X, or a half FEX. I mean a half FE, where is the extension, which is going to be a half F times X. For the second one, the elastic potential energy is going to be a half times F. Where there is extension, I'll put a half of X, which becomes a half into a half of Fx. And a half of Fx was the initial elastic potential energy EP. So this becomes a half of EP for only one spring. So extension is a half X, then energy is a half EP. So the answer is going to be A. The diagram shows a transverse wave on a rope. The wave is traveling from left to right. Left to right. Okay. So if it is traveling from left to right, then it means a particle here is at rest. Then the particles here are actually vibrating upwards. Then the particle here is at rest. Then particles here are vibrating downwards. Then a particle at Q is at rest. So a particle here is at rest, but the next particle will vibrate upwards, and so on and so forth. So which rule describes the direction of motion if any of the points P and Q? So we know Q is at rest. Q is stationary. So we eliminated C and D. But P is vibrating downwards. So it means our answer is going to be A. P is vibrating downwards and Q is at maximum displacement, so it is at rest. At maximum displacement, a particle momentarily stops before there is a change in direction of vibration. So P is downwards and the Q is at rest. The period of an electromagnetic wave in a vacuum is 1 nanosecond. What are the frequency and wavelength of the wave? So period is 1 nanosecond. We know frequency is equal to V over lambda, which is, it is electromagnetic. So it means we know the speed. So this is going to be, okay, we know frequency is equal to 1 over period, which is 1 over 10 power negative 9. 1 over 10 power negative 9, 1 divided by 1 exponent negative 9. So this is 3, 6, 9. 1 times 10 to the power of 9. I don't need even to check the rest. The frequency is 1.0 times 10 to the power of 9. So automatically it means the wavelength, this is 1 times 10 to the power of 9. So it means the wavelength is simply going to be V divided by F, which is 3 times 10 to the power of 8 for speed of light, divided by 1 times 10 to the power of 9. So it is just 3 divided by 10, which is 0.3. An observer is standing on a rail platform. A train passes the observer at constant speed while emitting sound of frequency F from its whistle. What does the observer hear? Of course, if the observer is standing somewhere here, when the train approaches, the frequency observed is higher, and when the train moves away, the frequency observed goes down. So let's see the options here. Sound of decreasing frequency as the train approaches, it must be of increasing frequency. For approach, it must be increasing frequency. Sound of a higher frequency than F as the train approaches, the first part of the statement is correct. And a lower frequency than F as the train moves away. So this is going to be correct. If the normal frequency is f, so as it approaches, f naught is greater, so that means f naught is greater than f. And as it moves away, it means f naught is less than f. So the answer is B. Which microorganisms have a length that is equal to the wavelength in free space of electromagnetic wave that is visible to the human eye? Of course, remember, for the human eye, the wavelength is of the order 10 to the power of -7. Remember, from red to violet. Red is 7 times 10 to the power of -7 meters, and violet is 4 times 10 to the power of -7 meters. These are wavelength. This is visible light. So we check these ones to see which one has that power. So this one is 0.5 times 10 to the power of, so this is going to be 5 times 10 to the power of -7 meters. This is going to be 5 times 10 to the power of -6 meters. This is going to be 50 times 10 to the power of -6 becomes 5 times 10 to the power of -5 meters. 100 times 10 to the power of -6 becomes 1 times 10 to the power of -4 meters. So the answer is going to be the first one, which is A. Two progressive waves overlap. What is essential condition for the two waves to form a stationary wave? Stationary wave, remember, stationary wave should have nodes and antinodes. Two waves cannot form a stationary wave if they are moving in the same direction. So the answer is going to be C. The waves are longitudinal. The waves are polarized. The waves travel in opposite direction. So whether transverse or longitudinal, as long as they move in the same direction, they will not form a stationary wave. To form a stationary wave, they must travel in opposite directions. So the answer is going to be C. In an experiment to produce a stationary sound wave in air, a fine powder is initially evenly distributed along the length of a horizontal glass tube, which is closed at one end. At the open end of the tube, a loudspeaker emits a sound wave of a constant wavelength. A stationary wave is formed and the powder accumulates in irregularly spaced piles as shown. Of course, we know that wherever we have a powder, there must be a node, because particles here are permanently at rest. Whenever we have a heap, there must be a node. So it means in between, we must be having antinodes. If you want to sketch this, you could easily sketch this something like this. Okay. So which statement explains the positions of the piles of powder within the tube? So the position where the powder is, particles are permanently at rest. The powder cannot be pushed away. So we have nodes here. That is where particles have minimum amplitude. So let's check. The piles are where the air molecules vibrate with the maximum amplitude. That is not true. That would result into an antinode. The piles are where the air molecules vibrate with the minimum amplitude. This could be true. This is where we have the nodes. So the answer is going to be B. So I will not check the rest. A sound wave of wavelength 0.5 meters passes through a doorway of width 1 meter between two rooms, which change increases the amount of diffraction. So for diffraction to be maximum, for maximum diffraction, the wavelength should be equal to the size of the gap. In other words, the wavelength should be equal to 1.0 meters. But the wavelength we started with is 0.5. So if a condition doubles 0.5 to become 1, then the diffraction is maximum. So double amplitude. So doubling the amplitude does not affect the wavelength. So this one is out. Double the width of the doorway, it makes it even bigger. So it means diffraction is minimum. So this is out. Half the frequency. So if frequency is halved, then wavelength is twice. So it will be 0.5 times 2, which is equal to 1.0 meters. And when the wavelength is the same as the size of the gap or the width of the gap, then diffraction is maximum. So the answer is going to be C. Making the frequency half will make the wavelength twice, which makes the diffraction to be maximum, because the wavelength is going to be the same size as the width of the gap. A light source consists of a vertical slit illuminated by red light R and violet light V. The wavelength of R is approximately twice the wavelength of V. A parallel vertical double slit is placed nearby. The white screen is placed so that fringes are formed on it. Which graph best represents the interference fringes formed on the screen? Okay, of course we know that at the center, each of these, the red and because both of them, red and violet, are being illuminated, they will both form. We expect both of them to form a maximum at this point here. But remember, red has from the diffraction grating, from the double slit formula, lambda equals to AX divided by D. The wavelength is directly proportional to the separation of the fringes. So that means, remember, the wavelength of red is greater than the wavelength of violet, which means X for red should be greater than X for violet. So if we have formed violet here, then red should be forming a bigger what? A wider peak at this point, but they have the same they will have the same amplitude. So let's check. So A is automatically wrong because A is showing that there is no, it's like the first interference pattern is beyond the point where it's not at the center, so this is going to be wrong. B is also wrong because showing that as if it's only violet which makes its first interference pattern at the center, which is also going to be wrong. C is going to be correct, I think, because we are seeing violet and red both forming an interference maximum at the center, and we are seeing that the width of red, this is red, is bigger than the width of violet because the wavelength is directly proportional to the separation of the fringes. D is going to be wrong because D shows this was width for red, this was for violet. This is width for red, and this is width for violet, which is going to be wrong. So C is correct because it shows the width for red, or the interference fringes for red are more widely spaced than those for violet. So the answer is going to be C. We just use the expression for the double slit to arrive at that conclusion. Which property of a light wave can be determined using diffraction grating? Of course, for diffraction grating, n lambda is equal to d sine of theta. So we have wavelength, we have the angle of diffraction. So amplitude is not there, we don't have intensity, we don't have speed in that equation, we have only the wavelength. There is an electric current in a copper wire. Which statement describing the average drift speed of the charge carriers in the wire is correct? Average drift speed. We know that I is equal to N. My students always say never, or NQVA. So there is a current, there's an electric current, so which it is nearly 3 times 10 to the power of 8 meters per second. That is the drift speed for an electric current. Which statement describes the average drift speed of the charge carriers in the wire is correct? It's nearly 3 times 10 to the power of 8 meters per second. This may not be true. The electric field is the one which moves through the field at a very high speed. It is proportional to the cross-sectional area. V is inversely proportional. It is proportional to the length of the wire. We don't see VL here, so This is not correct. It is proportional to the magnitude of the current. I think we see that I is directly proportional to V. I think the most appropriate answer is going to be D. I is directly proportional to V. A battery with a constant internal resistance is connected to a resistor of resistance 250 ohms, as shown. The current in the resistor is 40 milliamperes for a time of 60 seconds. Okay, that is the current here. During this time, 6 joules of energy is dissipated by the internal resistance. So this is the lost energy in the internal resistance. What is the energy supplied to the external resistance during the 60 seconds and the EMF of the battery? So to begin with, using VPD across 250, which is going to be the current times the resistance. This is going to give us the current is 40 times 10 to the power of minus 3 times the resistance, which is 250. This gives us the PD. I think this is 10. Yeah, this should be 10 because the power of minus 3 cancels. So this is 10 volts. That is the PD across the internal resistance. But remember, terminal PD is given by the EMF, or the energy is the energy per unit charge, electrical energy per unit charge. That is terminal PD. So this is going to be the energy divided by the charge, which is current times T. So it means the energy in 250 volts is going to be, I'm making energy the subject, is going to be the PD. Remember this was 10 volts. It's going to be 10 times I times T, which is going to be 10 times the current, which is 40 times 10 to the power of minus 3 times T, which is 60 seconds. So this is going to give us 6 times 4, I think that is 20. I think this is going to be 24. 6 times 4, that is 24. So the energy here is going to be 24 joules. That is the energy dissipated in 250 volts. So it means the total energy in the circuit, total energy is going to be equal to 24 joules plus the energy in the internal resistance, which is 6 joules, which gives us 30 joules. That's total energy. And remember, EMF is total energy per unit charge. EMF, by definition, is total energy available. Total energy per unit charge. So this is going to be 30 divided by the charge, total charge, which is IT. So this is going to be 30 divided by the current divided by IT. So that is 30 divided by the current, which is, what is the current? 40 times 10 to the power of minus 3 times the time, which is 60. So here I had to use both the definitions of the terminal PD and definition of EMF. So I have 40 exponent minus 3 times 60. Then I have 30 divided by the answer, which is 12.5. So it's like the EMF is going to be 12.5 volts. So the answer is going to be D. The energy, this energy supplied to the external, we have already got it as 24 joules, and the EMF is 12.5 volts. Which component has the IV characteristic shown? Of course, this is a filament lamp, because you notice that the resistance is equal to V over I, and we notice that as V increases, I also increases, but the V is increasing more rapidly than I, so it means the resistance is increasing because the temperature increases. So this is a filament lamp. Two wires P and Q have the same resistance, that is same R. Wire Q is made of material that has twice the resistivity as that of wire P. So if wire P is rho, then wire Q is going to be twice rho. So same resistance, or resistance of P should be the same as resistance of Q. The diameter of wire Q is twice the diameter of wire P. So if wire P is D, then Q is going to be twice D. What is the ratio length of wire P over length of wire Q? So from resistance is equal to rho L over cross-sectional area. Area is pi d squared over 4. So the 4 goes up. Area is pi d squared divided by 4. So it becomes 4 rho L over pi d squared. So remember, resistance of P is the same as resistance of Q. So I'm going to just come up with the two equal equations. So for the resistivity of P was rho, let the length of P be LP. Divided by pi, the diameter of P was D, but is squared. For Q, is 4, resistivity is twice rho. The length for Q is LQ divided by pi. The diameter for Q was twice, so it is twice D, but this is squared. So LP over LQ is going to be 4 cancels, rho has cancelled, pi has cancelled. So I have LP over LQ is equal to D squared divided by, this becomes 4D squared, which gives me, oh, there's a 2 here. 2D squared divided by 4D squared, which gives me 1 over 2. So the answer here is going to be C. A voltmeter reads 9 volts when it is connected across the terminals of a battery. So here it reads 9 volts. So that means 9 volts is going to be the EMF. EMF is 9 volts because there is no external circuit here. When a resistor of resistance 11 ohms is connected in parallel with the battery, the voltmeter reads 8.8 volts. So this is going to be terminal PD. PD across 11.0 ohms is 8.8 volts. This is terminal PD. What is the internal resistance of the battery? Okay, so we know that EMF is equal to the terminal PD plus the lost volts. Of course, the current is the same. So the EMF is 9 volts. Terminal PD is 8.8 volts plus the lost volts, which is going to be, the lost volts is current times internal resistance. That is the lost volts. But I can still find the current because I know the resistance, internal resistance here. The current I is also going to be the terminal PD divided by R. Terminal PD is 8.8 divided by the resistance, which is 11. That is the current, and I think this is 0.8 amperes. So it means 9 minus 8.8 should be equal to the current, which is 0.8 times internal resistance. So R is going to be, I think that is 0.2 divided by 0.8. What is 0.2 divided by 0.8? I think that is a quarter, which is 0.25 ohms. So the answer is going to be B. Each of Kirchhoff's laws is linked to the conservation of a physical quantity. Of course, we know first law is charge, second law is energy. So Kirchhoff's first law is charge, second law is energy. So the answer is automatically C. You have seen this question many times, so you are used to it. 3 batteries and their identical resistors are connected in a circuit PQR as shown. There are 3 batteries. The batteries have negligible internal resistance. Okay. What is the potential difference between points P and Q? So the voltmeter is going to be put here to tell the PD across P and Q. So first of all, I'm going to find the effective EMF by using Kirchhoff's law. For this, I'm going to find the effective EMF. So effective EMF by using Kirchhoff's laws. So it is the sum of the EMFs. So I'm going to move around in an anticlockwise moment. So this will be 9.6 minus 8.4 plus 6.3. That is by Kirchhoff's second law. So the effective EMF is going to be 9.6 minus 8.4 minus 6.3, which is, did I do it correctly? 9.6 minus 8.4 plus 6.3. So that is effective EMF is 7.5 volts. So because the resistors are identical, this effective EMF is going to be shared equally. So it means the PD across each resistor is going to be PD across each resistor is going to be 7.5 divided by 3. I think this is 2.5 volts. So the PD across this resistor is 2.5 volts. So what is the potential difference between points P and Q? So this is the PD across this resistor, and the EMF of the cell is 9.6 volts. Remember, we want PD, we don't want EMF. So the PD between P and Q is going to be equal to the EMF on that branch, which is 9.6 minus the PD across the resistance, which is 2.5. And I think this gives you 7.1 volts. So the answer is going to be 7.1. A cell, of course, this is a complex question. I know many people cannot really understand this, but it's simple. A cell E of EMF 2 volts and negligible internal resistance is connected to a uniform resistance wire of resistance 10 ohms and length 1 meter. Z is a connection that may be made to any position along the resistance wire. A galvanometer is connected between Z and a point Q. A new source of EMF of approximately 80 millivolts is connected between points P and Q. The EMF of the new source is determined by changing the position of Z until the reading of the galvanometer is 0. Okay. We change the circuit allows a much more precise value for the EMF of the new source to be obtained. Of course, a change which will give a much more precise value should give a potential difference, a PD across the wire, to be very close to 80 millivolts. So we are going to check this. Add a resistor of resistance 0.1 ohm in series with cell E. So we are putting here a resistance of 0.1 ohm in series with cell E. We are putting it here. Remember, the wire was 10 ohms. So let's try to find the PD across the wire in this case. The PD across the wire is going to be I'm using V out equals to R out over R total times V supply, or which is going to be the EMF E. So this is going to give us 10 divided by 10 plus 0.1 times E. What was E? E was 2 volts or 2000 millivolts. So times 2000 millivolts. What do we get here? So 2000 millivolts times 10 divided by 10.1. This is 1980 millivolts. So because this would give a high PD between along the high PD across the wire, it may be very hard, it may not give a very precise measurement for the 8 millivolts. Let's check the second one. The second one is going to be 1000 over 1000 plus 10 for the wire. No, it is going to be 10 because we are finding the PD across the wire. So it is 10 over 1000 plus 10 times 2000 millivolts. I'm multiplying by 2 volts, which is 2000 millivolts. And I think this is going to be 10 divided by 1010 times 2000, which is 19, approximately 20 millivolts. We notice that 20 millivolts is not very far from 8 millivolts. Then if this arrangement gives a PD across the wire to be 20 millivolts, then it is most likely going to give a more precise measurement of 8 millivolts. So the answer is most likely going to be B. Because 10 ohms is much smaller, it will give a value bigger than 20 millivolts. 800 ohms is smaller than 1000, to also give a value bigger than 20 millivolts. So it means the most appropriate is going to be B. Which statement about alpha particle scattering experiment provides evidence for the existence of the nucleus? Of course, a tiny proportion of the alpha particles are deflected through large angles greater than 90 degrees because the nucleus is positively charged. So I think the answer is automatically A. That one is obvious. We have done this many times. If most of the alpha particles pass through, it's because most of the atom is empty space. If a few alpha particles are deflected through angles greater than 90 degrees, it is because the nucleus has a positive charge and most of the mass is concentrated in the small, positively charged nucleus. A nucleus X undergoes beta plus decay. So X is giving us beta plus. Remember, beta plus is 0, 1. The products are a nucleus Y with the proton number Z, a beta plus particle, and another particle P. What is particle P and what is the proton number of nucleus X? Whenever a beta positive particle is emitted, this is an anti-electron. It is always accompanied by a neutrino, so P is going to be a neutrino. An anti-electron is accompanied by a neutrino, so P is a neutrino. So we eliminate A and B. First element A and B, because we know P is a neutrino. And if P is a neutrino, this is going to be, when I add, this is Z plus 1. What happens to the proton number? Of course, the proton number of Z, the proton number of nucleus Z has increased by 1 because it's like a neutron has changed into a proton. So the proton now, it's a neutron N10 has changed into a proton. This is how we get, a proton P11 has changed into a neutron N10 plus beta plus, which is 0, 1, then plus a neutrino. So the question is, what is particle P? And we have said that is a neutrino. And what is the proton number of nucleus X? So if I'm looking for proton number of nucleus X, to balance the proton number, this side I have Z plus 1. So they want a proton number of X. So to balance, this will be Z plus 1. So the answer is automatically D. I don't even need this equation. A particle consists of two up quarks in the charm. Remember the charge? An up quark has a charge of plus 2 over 3e. And the charm quark also has the same charge, plus 2 over 3e. What is the charge of this particle expressed in terms of elementary charge E? So we have up, charm. So we have plus 2 over 3e, plus 2 over 3e, plus 2 over 3e, which gives me, I think that is 6e over 3, which is plus 2e. So the answer is going to be D. I think that marks the end of October, November multiple choice questions. See you in structured questions. Until next time, bye bye.